Hey guys, this is Mrs. Sharp, and I just thought I would try to come up with a more clear-cut solution to some of the problems you're having with balancing these redox reactions in a basic solution. So I think I have. I think I've got it. I'm going to go ahead and pause the screen, or have Mr. Lewis pause the screen so that you can write down these directions in your notes instead. Essentially, I am having you, instead of following the directions I gave you, go ahead and follow the same steps as acidic, except for we're going to add a little twist to the end by adding OH minuses to each side to eliminate our H pluses. So, essentially, we are going to have H pluses and an OH minus together becoming a water. So, if you had two H pluses and two OH minus ones, you would have two waters. So that's what we're going to be doing. So again, I'll have him go ahead and pause this right now. You can let him know politely when you're ready to go on. And we'll do an example problem. Okay, so what I'd like to do, this is problem 30 on your assignment. And I will go ahead and copy down what we have here. We have Zn plus NO3, -1, that's a nitrate ion. And that's becoming a complex ion, ZnOH4 with a, that's a -2 charge, and our NH3. And so our first order of business here is to identify oxidation numbers. So to be quick, I'm just going to tell you what those oxidation numbers are. Zn would be 0, N would be +5 here. And this compound we'll talk about in a second. Zn is going to be +2, and N would be -3 here. The reason Zn is +2 here is because I know OH is -1, because the O is -2 and the H is +1. And since there's 4 -1s, I have to have a +2 to get an overall -2 charge. Let me clean that up a little bit here. So I'm going to go ahead and write my half reactions now down here below. And I've seen some trouble with your guys' half reactions, so I want to talk to you a little bit about that too. So first I have Zn, and it's going from 0 to Zn with this entire species here, and a +2. Before you write how many electrons are transferred, it is super important that you make sure the atom that is changing, or the ion that is changing, is balanced on both sides. A lot of you are forgetting that. So in this case, Zn is balanced on both sides, so I can continue. And I'm going to add my electrons over here, and that is an accurate reflection of what's happening. Now, for my NO3, -1. NO3 over here is +5. Over here I've got NH3, and this time as well, my atom of interest, or my ion of interest, is balanced, so I'm good. Now I want to go back and show you how to, well, hold on, let me add my 8 electrons here, sorry about that. Show you how I think is an easier or more clear-cut way to balance these in a basic solution. Remember, in a basic solution, what we have available are OH -1s and waters. But we're going to go ahead and balance this like it would be in an acidic solution, and then fix it. So here I've got my O's. So first I would go ahead and add 4 H2O's. And then normally I would say, okay, now I have 8 H pluses. So I would balance the side, so I had 8 H pluses, noting that I already have 4. So I would only need to add 4 H pluses to this side. All right. I will do the same thing down here. I have 3 O's on this side, so I need to add 3 O's to this side as well. That is a difference of 6 plus 3 is 9 hydrogens, so I'm going to add 9 H pluses over here. If this were an acidic solution, I would be done, but it's not. It's basic. So here's where I'm getting to the change. Instead of stopping here, I'm going to take this H plus, and I'm going to add 4 OH minuses to it. Because if I do that, that eliminates any H pluses and makes water, which is legal. However, to be fair, I need to add 4 OH minuses as well. Okay, so I added 4 OH minuses to each side. That made these not 4 H pluses and 4 H minus 1s, but 4 H2Os. Now you can see here, I think that with 4 H2Os on either side, could really clean things up by realizing if I have 4 H2Os on each side, those are just going to go away. So that leaves me with this. Let's do the same thing down here at the bottom. Now I can't have 9 H pluses, but I can add 9 OH minuses to each side. And instead of 9 H pluses and 9 OH minuses, I would have a legal 9 H2Os. Okay? And again, I see that I have 9 over here and 3 over here, so I can do a little cleanup right off the bat, get rid of those 3, cancel 3 out here, which leaves me with 6. Okay, now I'm ready to multiply. Since I have 2 electrons here and 8 here, I need to multiply this all by 4, and that should give me an even number of electrons on each side. So adding this up, 4 times 4 would be 16 OH minuses plus 4 ZNs plus 6 H2Os plus 8 electrons plus NO3 minus 1. So I'm just taking all of my reactants and writing them out. Even my electrons, because I like to. On my product side, I'm going to have 4 ZN OH4 minus 2s. Forgot to write that one here. I'm going to have 8 electrons. I am going to have an NH3. And I'm going to have 9 OH minuses. Okay. Now that I have everything that I've listed up here, I can do some cleanup. So first, let's just go in order. I have 16 OH minus 1s and 9 here. So 9 of those will cancel, leaving me with 7 on this side. Let's do ZNs next. ZNs are fine. Let's do H2Os next. I have 6 over here and none over here, so that's fine. Let's do electrons next. I have 8 over here and 8 over here, so that's okay. So basically that's what I'm left with because NO3s don't appear on the other side. So let's just make sure we're balanced. Let's do ZNs first. So I have 4 here and 4 here, so that's all good. Let's do N's next. I have 1 here and 1 here, so that's good. Let's do O's next. I have 7 plus 6 is 13 plus 3 is 16. So let's make sure we have 16 down here. Oh, that's easy. 4 times 4 is 16. And let's do H's last. I have 7 H's plus 12 is 19. It's kind of a weird number. So I have 16, okay, plus these 3, which is 19. So we're all good. So essentially, the only difference that we're doing here is we are adding that extra step after the acidic of adding enough OH minuses to each side to make water. And I think that should help you guys out a lot. So give it a try. I've got a key for the rest of the problems there for you to work on. And just the basic problems today that we're focusing on. All right, best of luck. See you soon.